Okay, in section 5 we're going to talk about parallel lines and triangles, and our essential understanding here is going to be that the sum of the angle measures of a triangle is always going to be the same. Okay? So we're going to start out with what's called the parallel postulate, which says that through a point not on a line, our point P here, there is one and only one line parallel to the given line. So given this line L and some point P, there is only one line that we could draw through P that's going to be parallel to L. Okay? And that's what we call the parallel postulate. And that's going to come into play when we start looking at some of these triangle theorems. Okay? So, first theorem we have is called the triangle angle sum theorem. Basically, all this theorem says is that the sum of all the angles in a triangle is always 180 degrees. Doesn't matter whether the triangle is acute, right, or obtuse. The sum of all the angles on the inside of the triangle is always going to be 180. So what we want to do is we want to prove this theorem. Remember, a theorem is a statement that has to be proven. So we're going to go through the proof of this theorem on the next page. So, the proof of the triangle angle sum theorem. So what we're given is this triangle ABC, and we want to prove that the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 is going to be 180. Okay? So the first thing that we're going to need to do is we're going to need to draw an auxiliary line. We want to draw line BD parallel to line AC. Okay? And what allows us to do that is because we've got AC is already a line, and we've got point B, a point that's not on the line, we're able to do this through that parallel postulate that we just looked at. Okay? The parallel postulate allows me to come up here and draw this line here, and we'll make this point D. So there's our line BD, which is now going to be parallel to AC. Okay? And by doing so, we've created some more angles. We've created an angle here that we'll call 4, and an angle over here that we'll call 5. Okay? So if we look at our diagram, I've got parallel lines. And because I've got parallel lines, I've got alternate interior angles with angle 1 and angle 5. So I know that angle 1 is going to be congruent to angle 5. I also have alternate interior angles at 3 and 4. So I also know that angle 3 is going to be congruent to angle 4. And I know that because parallel lines tells me that the alternate interior angles are congruent. Okay. So, next step. Okay. Remember, my goal is to get the sum of 1, 2, and 3 to all be equal to 180. So where in the diagram can I get something that equals 180? Well, I go to the top and I look at the 3 angles at the top. Okay. And all of those angles there form a straight angle. Okay. So I know that the measure of angle 2 plus the measure of angle 4 plus the measure of angle 5, all of those are going to equal 180. And that is nothing more than the angle addition postulate, because all those small angles add up to the one big straight angle, which is 180 degrees. Okay. So, if angles are congruent, kind of going back to step 2, then I know they have equal measure. So the measure of angle 1 is equal to the measure of angle 5, and the measure of angle 3 is equal to the measure of angle 4. And that's simply the definition of congruent angles, going back to the earlier chapters. Okay. So now that we've got that, we're close. Okay. Here in step 3, I've got a sum equal to 180. The problem is I don't have the right pieces. I've got angle 2, but I don't have angle 1 and 3. Well, in place of angle 4, I could put in angle 3. And in place of angle 5, I can put in angle 1. Okay, so with some substitution, I can end up with the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 equals 180. And that's simply going to be substitution. Okay. So we've now proven that the sum of the angles inside of a triangle is in fact equal to 180, and that will be true all the time. And that is our triangle angle sum theorem. Okay? So let's use that to do this next problem. What are the values of x and y in the diagram at the right? Well, in triangle ABD, I've got an angle of 43 degrees, I've got an angle of 59 degrees, and I've got an angle of x degrees. Well, within a triangle, I know that the sum of all the angles has to be 180 degrees. So if I solve this equation, that's going to give me 102 plus x equals 180, which means x is going to be 78. And then if I look at the diagram, the x and the y here, they form a linear pair. So if they form a linear pair, I know that 78 plus y has to be 180, which means the y is going to be 102. So we found that our x was 78 and our y was 102. So what's that going to make the value of z? Well, in triangle BDC, I've got a 49. I found that y was 102 plus the z, and I know that all three of those have to be 180. So this gives me 151 plus c equals 180, which means z is going to be 29. So just using that theorem that the sum of the angles in a triangle is going to be 180 degrees. Okay? So we will go over any questions you have on these in class, and then we'll do some practice problems together for an assignment in class. We'll see you then.